Welcome everyone to this webinar. It's a real pleasure for me on behalf of Université PSL to greet our audience to this session on tipping points on the occasion of the United Nations World Day to Combat Desertification and Drought. I'd like to greet our distinguished guests for this conversation on global challenges organized in partnership with the University of Arizona. I'm Emilienne Bannette, Vice President for International Relations at Université PSL. This webinar is one in a series of discussions Université PSL faculty, researchers, and students will hold with our global knowledge partners worldwide on critical issues and challenges which our communities are addressing globally, locally, and together, and which are at the core of Université PSL's priorities. These issues are of a complex and transnational nature. They can only be approached through interdisciplinary and international cooperation in research. So our intention in crafting this cycle around some of the United Nations International Days, which periodically highlight human and environmental challenges, is to open a platform for discussion across the boundaries of space and disciplinary specializations. I'd like to sincerely thank our panelists for their participation and commitment today. Professor Régis Ferrière, École Normale Supérieure PSL and University of Arizona, Professor Sharon Mcdowell, University of Arizona, Ms. Nikki Tully, doctoral candidate at the University of Arizona, and Mr. Germain Lostis, student at ESPCI PSL, who is joining us at the end of a day of exams and will accompany me moderating the discussion. Just a few words on our topic, tipping points. This is a key issue in the fight against desertification and drought, which is highlighted by this United Nations Observance Day, marked each year on June 17. This day was created following the signature of a UN Convention to Combat Desertification in 1995, and the idea of tipping points emphasizes the effects of soil management practices, water management practices, policies, cultures on desertification and drought. The 2021 theme of this day is restoration, land and recovery, and in the wake of the pandemic, we build back better with healthy land. So just a few words on the format. After 15-minute presentations, our three speakers will enter a conversation with each other and the audience. Members of the audience, you can already start submitting questions in the Q&A thread. Please don't use the chat, but the Q&A. Feel free to do that, and we will, after their speeches, we will open the conversation between themselves and you, the audience. The webinar will end at 7:30 p.m. Paris time, 10:30 a.m. Arizona time. So we start with Régis Ferrière. Welcome, Régis. With joint appointments at École Normale Supérieure Université PSL and the University of Arizona, Régis Ferrière is the director of the International Research Laboratory iGlobes, Interdisciplinary Global Environmental Studies, which is operated together between the Centre National de la Recherche Scientifique, CNRS, the ENS PSL, and Université PSL, and the University of Arizona, operated in Tucson. The iGlobes Lab promotes cooperative research between France and Arizona to study the social and ecological dimensions of living in extreme environments. As a mathematical ecologist, Dr. Ferrière works with an international team of students, postdoctoral associates, and faculty collaborators to understand how visible and invisible biospheres interact, evolve, and shape the habitability of the environment from local to global scales on Earth and beyond. Dr. Ferrière, the floor is yours. Your microphone. It's always the important detail.
Of course, I was going to do that. Thank you so much for this very nice introduction. I'm going to try to share my screen.
You stopped the sound again, Régis. Your sound is off.
I'm sorry about that. So I think that's working now.
We're good now.
All right, sorry. So I wanted to thank Dr. Bennett and my colleague panelists, and thank you, everyone joining us today on this very important day. As Dr. Bennett mentioned, I'm a mathematical ecologist, and one of my areas of research is the response of ecological systems to environmental change. And one important concept to understand and model and predict and forecast these changes is the concept of tipping points. So in this brief presentation, I'm gonna tell a few words about this concept and present the context in which we want to discuss it, to converse about it today. So let me try to advance my slides. So desertification. Well, desertification has been described as one of the greatest environmental changes of our time, and climate change is making it worse. While the term desertification may bring to mind the sand dunes of the Sahara, it's, as we know, an issue that reaches far beyond those living in and around the world's deserts. And in fact, the combined effect of climate change, the mismanagement of lands, and the unsustainable use of fresh water has seen the world's regions where water is scarce to be increasingly degraded, threatening the food security and livelihoods of more than 2 billion people, and jeopardizing biodiversity and compromising ecosystem function on large scales. So the extreme case of desertification leading to an arid desert will illustrate the ecological mechanisms that are at stake in the process, the general process of desertification, which involve nonlinear feedbacks and tipping points. So I'm going to take the emblematic case of the collapse of the Saharan vegetation to introduce you to the notion of tipping point as we define it and use it in ecological science. So what happens in the Sahara is that during the early and middle Holocene, so that's about 10,000 to 5,000 years before present, much of the region was wetter than it is today. And there was extensive vegetation covering the region and lakes and wetlands. And then sometime about 5,000 years before present, an abrupt switch to desert-like condition occurred. And we think by combining atmosphere models, ocean models, and biosphere models, experts think that feedbacks causing alternative states, stable states between a vegetated state and a desert state could explain this abrupt switch, even when the climate system itself was being driven by slow, gradual change in insolation in relation with subtle variation in the Earth's orbit. So what's the mechanism there? Well, the mechanism is illustrated there, where you can think of, I'm going to try to use my pointer here. There you go. Where you can think of the state of the system as being vegetation, and the conditions here as being a global continental index of aridity. So as insolation decreased for multiple reasons that I'm not going to describe here. The global aridity of the northern part of Africa increased, and a system that was vegetated originally decreased, see the vegetation cover decreased gradually, up to a point where this equilibrium state of vegetation cover could not be sustained anymore, and the system abruptly switched to a non-vegetated state, and even in the case of Sahara, a zero vegetation cover state, a desert, hyper-arid desert. To understand what happened then, it's important to realize that there are positive feedbacks at the local scale between vegetation and rain. Just to give you an idea, the benchmark number showing this feedback for the Amazon is that the Amazon itself, the Amazon forest, contributes about half of the humidity that falls on it as rain. So you have positive feedbacks between vegetation and rain. More vegetation means more rain, and in return, this promotes more vegetation. But now if vegetation decreases in cover, this means less rain, and this means less vegetation. This is how you can maintain this high vegetation cover equilibrium state. And this is also what maintains the low vegetation cover when the global conditions of aridity are high. You see an important aspect of this diagram here on the screen, which is that for a range of aridity conditions, these two states actually are possible together, okay? And if you perturb, for example, the high vegetation state a little bit, the system will go back there, will go back to its equilibrium. As long as the perturbation is not too large, above this dotted line here, the system will stay at its stable state of a large vegetation cover. But if the system starts with low vegetation, for the same global conditions, global climatic conditions, the system would stay in that state of low vegetation cover. So we have, this is why we talk about alternate stable states. The system has multiple stable states, and perturbations can actually shift the system between these states. So I'll come back to the consequences of the magnitude of these perturbations on the possible states of the system. So just to move forward here, desertification, the term itself, is a catch-all term for land degradation in water scarce spots, or the words that we call drylands. And these drylands cover about 42% of the Earth's land surface, a lot in Africa, of course, and Asia, but also Europe, Latin America, and large fractions of the North American continent and Australia. Today, we're going to focus on the North American dry West. So we're leaving Africa at this point, and we're zooming onto the North American dry West, where drought and excessive water use make a dangerously tipping cocktail. So if you look at the American West, well, it's dry. To speak of dry areas in the US is to speak of the West. The dry West covers an enormous region that spans the entire intermontane area and sprawls from Canada to Mexico across the western part of the Great Plains. In this dry West, you find true desert, hyper-arid desert like here in Death Valley, where the soil has been completely eroded or largely eroded and sand dunes have formed. But in many places, aridity is not that great. And instead you have semi-arid systems where the soil turns out to be actually quite fertile. And this promoted, after colonization of the West in the 19th century, a large development of agriculture. And I'm taking you to for a little tour of the Southwest here, Arizona in particular, where my colleagues and I are located right now. And it's very hot right now. We can talk more about that. It's remarkably hot. Well, agriculture, as you can see, can take a lot of land. And of course, it takes a lot of water. Mining, industry in general, and mining in particular. Arizona is one of the largest producers of copper in the world, and the mines are huge and they consume a lot of water and disrupt watersheds and affect water quality. And urban development, a megalopolis like Phoenix is located in the heart of a very hot Sonoran desert. And the urban sprawl is taking large stretches of the desert land around the city. There are side effects of these developments, like extra use of water for infrastructures like golf courses in the heart of the desert. And in some places, like the Santa Cruz Valley just south of Tucson, from where I'm speaking, you see all these things together happening: agriculture, the sprawl of a city, and mining. And in the middle, you see this poor river, the Santa Cruz, which is dry except for 4 small stretches that are entirely maintained by discharge of wastewater. So we end up with a situation, given the current drought conditions that we are experiencing, of potentially water wars of Arizona. And this is headlines in the New York Times from a few years ago, with agriculture using up to 75% of the water that Arizona can use for human purposes. And in the meantime, there are areas like the Navajo Nation where we're waiting for water. Water there is extremely scarce. Many of the Navajo Nation don't have running water, and we'll hear more about this challenge from Nikki in a moment. Just to show you the Navajo Nation here, it's a very large stretch of land in overlapping Arizona, Utah, Colorado, and New Mexico, with desert land, steppes, and also beautiful forest of ponderosa pines that provide a very precious resource to the Navajo people. And in this area, in this people, water is life. The sign "water is life" dot the rural landscape there. With a warming climate, the decreased rain and snowfall, the higher evaporation rates, and the drying up of surface water, the access to water has never been so problematic. So if you look at the headlines in the newspapers today, well, you see that 75% of California and 52% of the West are now in exceptional drought. And this is just headlines from various magazines, from The Guardian to People, telling us about what's happening. And it's happening right now. We have incredibly hot daily temperature, and the drought trend across the months, the years, the decades is incredibly worrisome. In particular, at the opening of this 2020, at the opening of this 2021 wildfire season, if we look back to last year, we see that we are now at 73 or 74% of droughts, whereas at the same time last year, we were at 3% of extreme or exceptional drought conditions. And you know what happened subsequently during the summer, these mega fires that ravaged California. And this in particular, as these mega fires ravage the drylands, ecosystem resilience of these can be overwhelmed. And this is back to the drawing I was showing you earlier. If you look at at an index like fire frequency and its impact on vegetation cover. As long as fire frequency is low, the ecosystem can maintain dense vegetation. But as fire frequency increases, we end up with this situation of having at least two alternate stable states. And if a large enough fraction of vegetation is lost due to fire, well, the system will shift abruptly to its low desertified vegetation state. So this is losing resilience as a consequence of increasing fire frequency and actually increasing fire intensity. So a major question, and I'm gonna end soon here, is the American West as a socio-ecological region, and many nested socio-ecological systems that are characterized on these maps. Are they on the brink of tipping over? Is the city of Phoenix that has been described as the most unsustainable city in the world can survive? Well, the United Nations are inviting us this year, and today in particular, to reflect on restoration of a degraded land by desertification. And this is really a major topic for a conversation about how much can we achieve with restoration, given the tipping point and alternate stable states that characterize the systems that are being degraded. Well, with this, I would like to thank my colleagues at iGlobes, especially the 2021 team with David Blanchon, who is really the expert on tipping points in socio-ecological systems, especially in response to water shortage, and Ruth Gosset, François-Michel Letourneau, and Sébastien Roux, who formed the French side of the unit at the University of Arizona. Thank you for your attention.
Thank you very much, Régis. That was really a stark and very clear reminder of where we are, especially the American West. As you say, this was in headlines in the world press this week. We were going to move on to Sharon Mcdowell. Professor Sharon Mcdowell is director of the University of Arizona Water Resources Research Center, and she is professor of environmental science. The geographic focus of her water policy and management work ranges from local to international. Some current research projects focus on groundwater governance, managed aquifer recharge, and transboundary aquifer assessment. Her engagement efforts include indigenous water dialogues and diversifying voices in water resources. Dr. Mcdowell endeavors to bridge the academic, practitioner, and civil society communities. In December 2020, she completed 12 years as an elected member of the Central Arizona Project Board of Directors, and she is active in many professional organizations. Sharon Mcdowell holds a PhD in economics from Princeton University. Thank you very much, Sharon, for bringing us your expertise to this panel, and the floor is yours.
Thank you so much, and thank you for the opportunity to be here today. I am going to share my screen and hopefully be able to show you my slides. And so I'm assuming in a moment, you'll see the slides in presentation mode. So somebody say no if that is not the case. So I'm going to focus on the drought part of the World Day to Combat Desertification and Drought. And it does relate, of course, to deserts and desertification because in the Southwest here where we live, we're in the Sonoran Desert. There are other desert areas. And as Régis started, I thought of a mnemonic tip that I learned as a child, learning the English language spelling of how to remember the difference between dessert and desert. And dessert in the English language has two S's, And it signifies it's something you want more than one of, where desert is not something you really necessarily embrace. So I just thought I would share that with you. It reminded me of that. My presentation today consists of 3 parts. I want to share with you an overview of the Colorado River Basin. The Colorado River is a highly managed river system. This photo here is of Hoover Dam, which is a major dam in the system. I want to address the shortage conditions in Arizona in particular, but the whole basin is under stress, and talk about it as an example of a tipping point situation. And then I want to end with some words about process and stakeholder involvement to address wicked water problems. Interestingly, just about 3.5 weeks ago, I co-chaired and hosted the conference of the International Arid Lands Consortium on challenges to arid lands. And the executive secretary, actually, of the UN Convention to Combat Desertification and their chief scientists were both speakers at the conference. And at the end of the conference, we put together some message having to do with this organization. But I thought I'd share with you this quote. The message is clear: regional and global multidisciplinary collaborative efforts are necessary and urgently needed to address these severe environmental challenges. Acting locally is not enough. So I very much appreciate the opportunity today to connect some communities across the ocean to talk about these issues. So regarding the Colorado River Basin, it's a highly managed system. The water from it supports 40 million people in their activities in one way or another. The whole system relies on river water, groundwater, some other water sources. There are 10 states in the United States, 7 states in the United States that share the river's water. There are 2 states in the Republic of Mexico. We have different systems of water governance and management across the states and across the international boundaries. And so it's very, very complex. And for those of you who may be interested in kind of the governance and institutional aspects, it's extremely interesting. And a lot of people spend a lot of time studying it, attempting to understand it, and attempting to address the challenges. There is an international treaty between the US and Mexico, and the federal agency, the Bureau of Reclamation in our US Department of Interior, plays a very substantial role in working with the states and internationally and with the local communities on management of this river system. And on this map here, I say Tucson, Arizona is where Rajesh and I live, and Nikki is a student. So we're in the southern part of the watershed, which is shaded here as an upper basin in green and a lower basin. And we call all the laws that deal with the allocations and the management the law of the river, but it's not a single law. It's a very complex set of laws, regulations, court cases, and the like. Now, the river and the river system is not in good health. We have 2 large storage reservoirs. Here's another photo of Hoover Dam on the bottom. Behind it is Lake Mead. It's a storage reservoir for water for the lower basin states of California, Arizona, and Nevada. There's another large dam that behind which forms Lake Powell. And then there are some other storage reservoirs as shown on this graphic to the right. And this graphic on your right is something that is shared every month with the Central Arizona Project Board of Directors based on data coming out of the US Bureau of Reclamation. And the sizes of these buckets represent the relative sizes of the storage reservoirs. So you see that Lake Mead and Lake Powell are the big reservoirs. They're very important to the management of the system and the deliveries of water to the states and communities served by the river system. And the blue part of the overall bucket is how full it is. And the white part represents how unfull it is. And also the shape of it, while not entirely accurate, shows that it's kind of it gets narrower as you go down. And so as of late April 2021, the reservoir, the Lake Mead Reservoir, was 39% full. And it's been well under 45% for some time. Lake Powell was 35% full. And this red line here is like a red line of when is there a shortage officially declared, that we really see some cutbacks in the river system. And what's really been alarming people lately is not that we've known we have these challenges, we've known that the river is over allocated, and I don't have time to go into the history of why that might be the case. But clearly the climate has been changing. And while this lake was virtually full around the year 2000, it's just been declining ever since. And if you look at the May graphic, so here are the figures as of the end of May, we've now gone down to 37% in Lake Mead. And we've gone below this red line, indicating that likely for 2022, we will have this tier 1 shortage. And what is surprising is that how quickly Lake Mead is going down. And this is where I think the tipping point concept really becomes kind of pertinent, that people can relate to. This is not a linear system. It's not like things will go slowly and slowly and slowly. People recognized a few years ago, we were getting to a tipping point where that it was nonlinear and the whole system could crash quickly if actions weren't taken to make sure that the storage reservoirs do not fall too low. And so that started 2018-19. It turns out 2019-20, that winter was a very good winter, but now we've had, it was 2018-19, excuse me, was the good winter. We've now had some very poor winters. And so we are at a situation where people all over the world, and certainly in the United States, are writing almost daily about the crisis of the Colorado River system, the heat that is being experienced. We're having record heat, and 2020 was a record dry and low hot year for certain areas within the basin. 2021, we're hoping we get a good summer monsoon, but time will tell if that's the case. And so here's just an example of a snapshot of an article. Red alert, Lake Mead falls to record low levels since it was full, since it was filled in the 1930s, a milestone. And if you go on Google News, I did this just a couple of days ago, June 10th, you just see so many photos from so many sources talking about the problems of the system. And here I wanted to share some photos, as Regis did, showing some of our terrain. This is what Lake Mead looks like. It's at lower levels. You see these bathtub rings, these calcium salt deposits from where the water was and then subsided. And it's beautiful. It makes a nice view from the air, but it's not what we want to be seeing in our storage system. And here's a photo of projections of Lake Mead elevation, which are used to determine cutbacks of water deliveries. And so you see the projections in the early part of this decade are not looking very good. And then this is a graphic that was just in the New York Times last Friday, just showing June drought conditions in the West. And you can see, if you just take a glance of the last 20 or so years, or a little bit less, you see that things are looking very bad here for this time of year in this whole western part of the country. And in fact, I think the New York Times has an article today, or somebody does, saying It is horrible in the West, and the summer hasn't even started. I think they wanted to get that story in before the summer solstice. So talking a little bit about addressing shortage conditions, this map on the right shows you average precipitation, kind of average over 30 years in Arizona. And as you can see, most of the state is brown, reddish, not green, where there's decent rainfall. So we live in a semi-arid environment. We actually live in a beautiful desert. And then there are upper highlands with forests. I mean, it's a beautiful state to come to. And I hope some of you who haven't ever been here will visit us. But we do have a diversity of water sources. We do have river systems such as the in-state rivers, the Colorado River. We rely on groundwater. We reuse some water for some of our supplies. And then if you look at the distribution of uses, 70% or more is diverted or extracted by agriculture. Municipal use is the growing use, and we also have industrial use, mining being one prominent example of that. I will note that we tend not to recognize the environmental sector by measuring its water needs and demands, which is why the Department of Water Resources puts out graphics like this that show the other sectors. And then here's a slide I wanted to show you again in the middle lower part to show a bit of the terrain that the Central Arizona Project, which is a constructed concrete line, large canal, travels through, meanders through. It pushes water uphill. It is the biggest user of electricity in the state. It's long, it's built to deliver quite a bit of water annually. But here's a real challenge. In order to get the funding to build the project from the US Congress, and the Arizona people are paying it back, we had to agree to a relatively low priority of on the system. So when there are cutbacks, we're among the first in Central Arizona experiencing cutbacks. Recognizing, as I indicated earlier, that there were potentially precipitous drops in the storage in the near future and wanting to bolster it, bolster the system, parties got together, the federal government, the states, the tribal nations in the states, and developed a plan to try to keep things from crashing. There is burden associated with it that had to be mitigated, particularly for Central Arizona farmers, because they're the ones who are the first hit by these shortages. And on the right is a block showing these tiered different shortages. I don't have sufficient time to go into this other than to say that right now, things are not looking good for 2022. And so the agricultural sector in Arizona is looking to use less surface water, still some, but go back on groundwater. And we have major issues of groundwater management in our state, a topic for another day. So my part 3, which will be short, is just some remarks on stakeholder involvement and process. I mentioned in my introduction of the concept of wicked water problems. I provide a link here to a professional magazine. These are not academic type articles. I encourage you to take a look at that. And Professor Bennett, you're welcome to post or do whatever you would like with this presentation so people have access to the slides. But wicked water problems, or wicked problems in general, have tremendous, you can't address them with a single solution. They require a lot of work, and they require a lot of people working together on them, and they are. But I wanted to point out the factors that help mitigate these problems through developing pathways to solutions are things that some of you may think, well, aren't they out there? But they're not always. Functioning cooperative mechanisms, trust and mutual respect, stakeholder involvement, good communication, being able to meet each other and talk. And of course, education is extremely important. So I want to close by sharing a slide with you. We offer an annual conference. I realize that we're far away from some of you. but we're offering it virtually in 2021. Registration is free and already open. So I encourage you to maybe take a look at either our website or go ahead and register. I provided the link to hear about webinars like this one. We publish information not only on our own webinars, but on others that we partner. And so I want to thank you for the opportunity to be here today. I want to just mention two things in my final closing here. And one is, as I was sitting here listening to Rajesh, I actually put this glass on there, the glass half full, because, and it's half empty. It's both. And I think with the involvement of the younger generation and those of you who are studying and working on these issues, we can look at the half full part, because we're going to work together to develop solutions. And I also want to note that several years ago, I visited the Paris sewers. I've been to Paris many, many times. And I hope post-pandemic, I have an opportunity to get back and maybe see some of you. So with that, I'm going to stop sharing my screen, and thank you very much.
Thank you so much, Sharon. That was really super interesting insight into policies and the way stakeholders can be engaged in solving these problems if we get there on time. I'm going to move on now to Nikki Tully. Miss Nikki Tully is an indigenous scientist from the Navajo Nation who is a PhD candidate at the University of Arizona in the Department of Environmental Science. Her research focuses on how climate adaptation influences water resource management approaches in indigenous and rural communities. She is an Alfred P. Sloan 2018-2021 scholar, American Indian Graduate Center Fellow, and an American Indian Science and Engineering Society Sequoia Fellow. Ms. Tully received a Bachelor of Science degree in Environmental Science and a Master of Science degree in Water Resources from the University of New Mexico. Nikki, the floor is yours. Your sound is...
Yeah, I was just making sure I had everything set up right away. Hi, my name is Nikki Tully. Today I will be presenting to you on a presentation titled Tua'eina, a Navajo Perception of Drought. So what Tua'eina signifies and can be translated more or less into is water is life. And what I'd like to draw your attention to in the title is one word, and that is perception. And so I chose perception over perspective due to the nature of this presentation. I come to you to make this presentation from a unique characteristic that I hold in the diversified knowledge systems that I bring to you. And one is that I am, as mentioned, an indigenous person. I'm a member of the Navajo Nation. And as such, I've been brought up in the ways of my people, but I am also in academia right now. And so what I am striving to do in the work and research that I do is bring these two knowledge systems together to be able to look at these topics such as drought and desertification. And so I wanted to share with you that this picture behind my title slide is a current common view that you'll see on Western Navajo, which you can see some of the dust blowing around, which in a general sense, you see the impacts of drought and desertification. But before I go any further, I'd like to play a short video for you. And this is in the Navajo language with subtitles in English. And what I hope to show with you this video is to really encompass a view, but also the language and the land of the people and a perception of drought that is amongst the Navajo people. And so I will share more about this this project that is associated with this video, but I would like to share these 2 minutes with you in the form of this video right now.
Equitable, Tochido in Ado endeta, Tolahate ego eya, not laws, Adiki eya as dahat not losh betro, Villa ashla betro, endeta late not say betro. As ego eya kondiki eya. badahwana nleda tro besto badana ahata joita te ya etronta los enda tale ya konte ki ya tronat los ki ya etlesh behal khadeki da chita ado enda ta kwige eta khwalpeo ta aketchen it los edo ta ya han sogota ya tide nal los pato le winzego diki ya akwege han sogoshi ya datenslen da agil in leko akonde do yegon haltjeno tide tronat loze abitje na hantla kodan da de yol Klej da kode da trago da nas trandle ado indita beshil wodiki troil wodiki beshna patliki da atat koda ya troha o ndal sa do handl sogoshe troha ya atendl diki ya ko trohaki johut ego to Ajiko sto okut ego hilt ego na hot ille.
And so why I shared this video with you today, I found it really relevant, and I appreciate the way this discussion started off today, mentioning the importance of interdisciplinary work that comes as a result of human-environment relationships in this discussion. And I find it in that interdisciplinary discussion also should include this indigenous perspective that was shared with you in this video, that this relationship and understanding of desertification and drought also come in the form of understanding in this form of perception a little beyond than the numbers and technical aspects that we're usually aware of in Western science. And so I show you this picture here to remind us that we're in an ever-changing world. And so this is a fossil that I recently found in the area where I grew up on the Navajo reservation. And if you look really closely at this fossil, you'll see some seashells in there. And so what this is evidence from over 100 million years ago of the water systems that once presided here in Arizona, northern Arizona, where I'm from. And so now you wouldn't be able to tell that and believe that there was water in such abundance before, but there is this evidence through the remnants of the fossils. And that red square just shows you that location in the map. So on this notion of perception and from a Navajo perspective, I'd like to share off with this first and a grandmother's teaching. So here on the left-hand side is my grandmother who lived nearly to be 100 years old. And I've learned, she was really my first educational system before entering Western science, academia kind of topics and learning settings. And so along with my other grandparents and parents, what I learned amongst my people is that there's this understanding that everything has a purpose and the relationship to the overall ecosystem and how we understand these systems. And so, for example, here on the slide, you now see a mound for some ants. And so even we are taught that even the tiniest insect can be a messenger to us to let us know about the system, to let us know about the types of season we'll have, the type of what time of year it is and how they're interacting with the relationship. And this really goes into this human and environment interaction. And so now you see this picture of a horizon with the sun coming up. Watching the land to the relationship is something that my grandmother would do, where she would be able to tell the cold days are coming, the hot days are coming, this season is beginning to start, this season is beginning to end. And it was all by her moving her thumb across the horizon, being able to tell those points. But towards the end of her life, there was something that we found her, my family found her to start to say, and that was, and so what that more or less means is that there's this pattern out of sync that she witnessed over the decades of her life that is now beginning to change. And now there's not scientific evidence behind her words, but as I move through this presentation, we're going to see how some of these models and these data sets can kind of mimic what her understanding of making that statement was of these changing patterns across the landscape. To bring that home a little bit more, I'd like to share these two words with you in Navajo, Atso and Yashdash Chile. And so this is really how we identify these months of May and June that are in relationship to planting. And I show you this picture here just to show you that this year we lost pretty much all of our fruit on our fruit trees. And so everything was going good, but all of a sudden a big freeze came. And so these are singular events of showing these landscapes. However, there is now this understanding that there can be other interdisciplinary ways to show these changes as well on a larger aspect. And I'll describe a little bit of that in the presentation in a few minutes. And so here you see a blue circle, and that's the home I grew up in, but there's two larger rectangles, a large rectangle and two smaller rectangles you see. These are evidence that I've seen over my lifetime of the impacts of desertification and drought in the area, even before learning about the technical sense of it. And so there, the big one, you kind of see the desertification impacts to the agriculture lands that were once vibrant. You see the increase of sand dunes and the migration there in the two smaller ones. And so I thought I'd start off with that. And before I even get into the political boundaries of where the Navajo Nation is located, I like to share this with you first. And so this is our Navajo Nation flag and the Navajo Nation seal. What you'll see on here is 4 mountain symbols. And what that signifies is how we identify our place in the world and where our homeland is at. And the rainbows there that you see on both represents this, this form of sovereignty. So we are a sovereign nation within the United States. And so this is just to go more or less to show you how different human and environmental relationships exist in the world today. And so the Navajo Nation, as stated before, is located in 3 states. Within the Navajo Nation, there's 5 agencies, 110 chapters, which could be likened unto municipalities. And right now, we're the largest tribe in the United States with nearly 400,000 members. And so this is the political boundaries of where you'll find the Navajo reservation and within the states of Utah, Arizona, and New Mexico. And so as was mentioned before, again, was that there was this tipping point that came forward in 2020. And as all of us are quite aware of the scenes in our own communities, I thought I'd share with you how it looked in the communities that I'm from. And so on the Navajo Nation, COVID-19 has been translated into the Kosinsaiki Nahestet. And so what this is showing here in these pictures was just the vast impact. And I'm sure some of you may have read in the newspapers across the world about the big impact that it had on our tribe. And so what was highlighted during this time was water access, water quality, and the lack thereof in the food deserts as well. And so just imagine that you're going through this pandemic, but imagine that you have to go out and to haul water, but not only to haul water for yourself to drink, but to clothe, to bathe, to clean, to bring water for your livestock, for your family. And so we're told by the CDC here in the United States that we should stay home, but when you're put in this predicament, there's a whole nother concept of difficulties that come from hauling water. And so this is really where I associated the topic of today, this tipping point in 2020, as a result of that, this water hauling population on Navajo was this formation of the Water Access Coordination Group came about. And so what this group did was establish transitional watering points across the Navajo Nation to increase water access in this time of drought and desertification that there's evidence across the land, to bring this access to water in the light of COVID-19. And this was all throughout 2020. And so the pandemic coupled with drought, there's many difficulties that have been and impacts that have occurred as a result of these major life changes and impacts. And this here is just to show you a couple of titles stemming over a couple of decades. And so one of these came from 1996. And in 1996, there was a pretty bad year in which as a result came some technical reviews and drought contingency plans that came into the works to address these issues. And why I show you this slide here with these titles is just to show you the ongoing impacts that drought has across the Navajo Nation and the work that is being done. And so I bring you to this slide here now. And so this is one of the technical reviews that came out in 2013 as a result of that that strong year of drought in 1996. And so here you see on the slide, for about the past 20 years from January 2000, that you see this huge impact of the below precipitation, the below average precipitation as a result of these SPI values. And there on the left-hand side, you see the impacts of the long-term and short-term droughts that you have now seen as evident in the videos and the pictures that I have shown you thus far. And so now we're moving into this numerical concept of identifying drought. And this is what I'd like to wrap up this presentation with. Is I told, as you know, I'm a PhD candidate right now in academia, and I am working in collaboration with NASA on this drought severity evaluation tool. And so here, the project team leader, Dr. Amber McCollum, with the other members of this project are listed here on the slide. And so this work here came as a result, again, to help and mitigate ways to identify drought and to report on drought. And so this DSET, the Drought Severity Evaluation Tool, was a funded project from the Western Water Applications Office from NASA, which was co-developed with the Navajo Nation Division of Water Resources and the Desert Research Institute. And why this is unique is that these entities work directly with the tribe to be able to develop this database to meet the 4 areas and the needs of the Navajo Nation, to make this a free web application, user-friendly, time and storage saver, and that the analyzing and visualizing data would be made easier. And so this is just to show you how the platform works, taking ground data, satellite data, and the model data sets together to go into this platform. And this is all available on the web, on the cloud, and that makes it easier for people on the Navajo Nation to access to this tool to create maps such as this to identify the 180-day SPI value for the Navajo Nation. And so this is looking at from June 9th. And as you can see, on June 9th, the majority of the Navajo Nation is either in severe, extreme, or exceptional drought. And so there's 2 opportunities in this platform to make maps or to make graphs. And so this is just a walkthrough that I brought to you today to show you the work that is being done in the perception of drought from the Navajo people themselves, but from also individuals and groups such as the WACG and from NASA, all coming together in this collaboration to address this issue. Thank you.
Thank you so very much, Nikki, for this insight and everything you've taught me, certainly, about associating these systems of knowledge and then all your own knowledge of the Navajo sense of place. Thank you very much. I'm going to turn now to Germain. Germain Lostis is a student at USPCI PSL, student in engineering. And I would like to thank him particularly for being here after a day of examinations. It's very brave of you. Germain, you are a participant in a student collective called PSL Anthropocene. Can you tell us a little bit about that before we start our conversation with our speakers?
Thank you for those elements. Yes, of course I can. Indeed, there is a clear need among students in the PSL community to grasp the major dynamics at work, which are highlighted by diverse scientific communities with nuance and rigor. Indeed, in the face of the disruptions to come, we must take our part in our collective adaptation to the new realities imposed on us by the Anthropocene. The student demand emerges from mobilization, meetings, and various projects. This is why in June 2020, the working group was created with a dual purpose to take advantage of PSL synergies to try to respond to this demand and to locate the university at the heart of a major issue. We started from the observation that we do not have enough information on these subjects, which should, however, involve most of us. The ecological emergency, including climate change, collapse of biodiversity, depletion of resources, including water, pollution has triggered a strong awareness of the need to act in this direction. And the contribution of PSL as a university allows for the addition of the component institution on competencies. In addition, there is a real multi-institutional logic that supports this cross-disciplinary dynamic. Our university makes sense around a project like PSL Anthropocene, which is a trans-scientific project in the sense of the rise of TOV. PSL Anthropocene will allow us to situate ourselves in relation to environmental issues for our future professional lives. The objective is to offer awareness through the arms of leading research at PSL in this area. PSL Anthropocene takes the form of 7 seminars at the beginning of the school year where researchers from different fields of the community propose avenues for reflection and action. With this project, the university will position itself as a leading figure in these major and new civilizational issues. They require diverse scientific approaches in which the university has proven itself, but also new ones. And I just got a question for Nikki, especially for Nikki, who is still a student. It's how is your engagement helping you for your work?
Yeah, so thank you for that question. So one aspect that I didn't mention in the presentation that I'm working with is a group here at the university called Indigifuse. And so that's the Indigenous Food, Energy, Water, Security and Sovereignty Nexus. And so what that work does is works directly with communities on the Navajo Nation to address issues such as food deserts and also water quality and water access through the incorporation of water filtration systems. And so that is one direct way that my studies currently as a hydroscientist and working with these groups at the university, with NASA, with the Navajo Nation is really coming into play in almost real time of putting what I'm learning into practice.
Thank you very much. Thanks, Germain and Nikki. So we're going to open now to our conversation. Regis, Sharon and Nikki and Germain as well, please don't hesitate to jump in. We do have one question here, which I would like to address to Regis. It is from Alain Fuchs, who thanks you, Dr. Ferrière, for this very interesting and impressive presentation. I enjoyed, I'm quoting, the stability limit model based on the hysteresis phase transition theory in statistical physics. I was wondering how it would be possible to get back from the dry state up to the F1 point, and if so, if you expect the system to be able to return to the wet state through a spontaneous phase transition. And from that model, I think we can afterwards move on to Sharon on a question concerning policy.
Yes, thank you. Thank you, Dr. Fuchs, for your question. Well, it's the $1 million question, right? How do we revert to a state that we deem favorable? Well, what the model shows and the concept of a tipping point with this alternate state is that it's very hard, right? If you revert the change in the environmental condition that drew the system towards the favorable state to the unfavorable state, you see that you're going to have to push the system, the environmental conditions, way back into their lower range, according to my graph, to get back to a state where the system, to a condition where the system will return to its favorable state spontaneously. So this is so the message is that it's not by returning to the tipping point of the environmental condition that you're going to improve things. You have to work much harder in order to drive the system without any further action back to its favorable state. So I just alluded to a possible way out of this conundrum, which is actually combining this effort on the global context of a problem. Well, first of all, you have to prevent further degradation. You don't want to go deeper into the bad conditions. You have to revert these bad conditions, and you have to somehow not just wait for reaching the first tipping point and the system moving back spontaneously to its favorable state, but you have to work on your global conditions together with some direct action on the system, short-term action, in order to perturb it in a good way, to move it back to the basin of attraction, the set of conditions that will drive it back to its favorable state. So it's that's the general concept, right? We don't want things to get worse. We want to improve the context, and we want to perturb, so to speak, the system to send it back to its favorable state. And all that requires very elaborate restoration plans that are, of course, highly specific to the system that we're talking about.
May I add, to a little bit here to Rajesh's response? Because from the modeling point of view, of course, we've got human and natural systems. And I just wanted to mention a few things about the concept of restoration and the concept of resilience. At that conference I mentioned at the beginning of my remarks less than a month ago, there was mention of, what is the definition of resilience that we're using or considering? And in fact, we're using it in our conference title for late this summer. Is it a bounce back to where you were, or is it an adaptive response that you improve, but you don't necessarily get better, back to where you were? And I did some work characterizing environmental restoration and enhancement projects. And we started using the word enhancement because, as Rajesh said, we didn't want things to get worse and we wanted to make them better, but we couldn't necessarily go back to where things were before the humans had such impact. And so I wanted to just bring in two other things related to kind of the human part. And that is, as we've looked at the tree ring records, the experts for the Colorado River system, the drought we're experiencing now is the second worst on record. And the hardest part of it is we don't know when we're coming out of it, how long it is going to be. So the term mega drought is being used, but we just don't know. But back then, when there was such a drought, we didn't have all this development of the water systems, and we didn't have all these people. And so these questions about the built environment and modifying how we envision our communities and so forth is part of that kind of resilience, adaptation, and whatever that I just wanted to mention. And Rajesh, I think I would disappoint you if I didn't notice that not everybody agrees with that characterization of Phoenix as the most unsustainable city. That was written by an author. If you would talk with the Phoenix water managers and leaders, they would say, we're planning, we have to adapt for sure, but they would not agree with that characterization. So I just wanted to offer those few comments.
If I may add to that a little bit, I would also emphasize that, in these simple graphs where we define the tipping points and try to quantify the resilience of the system, which is basically how large the perturbations of the system can be without altering the equilibrium state. In this representation, I used two axes, right? Horizontal axis for the environmental context, environmental parameter, climatic parameter, and a vertical axis for the state of the system. Well, in fact, on the horizontal dimension, you have many factors, many dimensions. And on the vertical dimension, the state of the system, you also have many variables. So, this idea, just to echo what Sharon just said, of can we be hopeful of restoring a system to a previous state? Well, this question is wicked. I think we don't know what previous states are, given that all these variables, all these parameters change. So moving the system back to a previous state is moving the system back into an unknown state, actually. And so a lot of modeling is now trying to actually put some parameters, some constraints of the space, the set of these possible reachable states by restoration when you try to move the system back to or away from the trends or the current perturbations.
Thanks, Régis. I have a question here that came in the chat, and I think each of you can think of an answer to it, and Germain included. It's very relevant. How are you using your collective work to push for sound environmental policies, knowing that it is an entire way of life that needs to be redesigned? The US being a country whose entire social and economic activities depend on fossil fuels, which exacerbate the current drought desertification situation. And of course, it's not only the US that's in this case. So I think you can all come up with an answer. Who would like to start?
Well, just to give a little bit of context, so I'm a basic science practitioner, right? Applications, I'm very interested, and I try to promote applications by working with collaborators and colleagues like Sharon, and this event today is a wonderful opportunity to interact with also students like Nikki and Germain and the whole community. But looking at my naive view of the response of the community to basic science work, what you read in the newspapers is not really the reflection of my effort as a basic scientist. It's more like grand ideas, like how can technology rescue us? So rather than looking into the detailed mechanism of the problem, we just jump to altogether alternative ways of approaching the problem. In the news last week about the shortage that Arizona and the Colorado Basin is facing, there were entire articles about this resurrecting this idea, or just entertaining this idea of a new canal, a new channel between to bring the Mississippi River, the Mississippi water into the Colorado. So that's just to give maybe exacerbate or amplify the question. It's a long way to feel an influence of basic science and basic understanding on solutions that we can bring to these problems. So now Sharon, who is hands-on and in the heart of things, can give us a real everyday experience of this translation or transfer of knowledge.
So I'll be brief because I also want to give our other panelists a chance to respond. And there, as always happens in these sessions, questions start coming in, as we're getting toward the end. But I would say that there are, I'm going to give a very general response about changes in policy that include environmental policy, but maybe other policies as well. Is that what I see and hear a lot is that people are really, and I'm using this word deliberately, they're thirsty for understanding the potential to implement solutions. And so what those who determine policy tend to say is, okay, I get it, or maybe some don't, but I get it. But rather than just talk about the doomsday, tell me about the solutions and tell me about the trade-offs that exist with these solutions. And so I think that's where the interdisciplinarity, the transdisciplinarity, the whatever you want to put in front of the word becomes so important. And as was mentioned earlier, where that bridging comes in, we have to bridge, we have to be able to communicate the science, we have to be respectful of people's different backgrounds and views. and really get to talk about it. But I would say that people were very divided in the United States in many ways, and that division, you know, carries over into some of the policies that we see advocated or rejected. And so I think that having more people understand the opportunities to address things and the trade-offs and the costs will go a long way toward developing better policies. I think if I'm speaking now to a purely, community group, I think I have to say something like, this is suggesting we can't go forward business as usual. I think we've been going to this point. This is where the tipping point comes in terms of kind of the social ecosystem. We have to think differently. And so I think it's going to take a while. People are resistant to change. And then it rains and they think the drought's gone. So one good rainfall or one good season is not going to fill Lake Mead or our aquifers or help us all that much.
Thank you very much. I'd like to turn to our young people because, as you said, Sharon, it's really a major reframing, not only of the way we think and understand things, but probably the practices. So who would like to address this question on our collective effort to change policies? We can't hear you, Jana.
Now, can you hear me? Okay. It's a little bit different for our student initiative because we are speaking from something which the objective was to evolve things at a different scale. But our role was to aggregate everything. So we do not have a collective. We have a collective work, but not for environmental policy, but at an internal scale for our university. So
yes, but that's already a collective effort. And Nikki?
Yeah, so as Dr. Mcdowell has mentioned a couple of times now that I really feel to answer this question, and I know it probably has been said millions of times, but I think it really does come down to inform, educate, and communicate, and that there's just a vast array of diversity that comes into human and environment action and relationships that go into these policies. And as we make sure that all who are involved in stakeholders and institutions who have that seat at the table, that those perspectives are taken into account, I really feel that that is a way that environmental policy can really take a little twist in incorporating those ideas and solutions that some may have that others have not thought about, or that in a different way to address it. And to go to the point of the question, that when the quotation marks and the way of life, I feel that that could be shown in an example that I mentioned in my presentation with the water access coordination group and the transitional watering points, in a way that quick response in the wake of the COVID-19 pandemic was a big response in for the people themselves, that you're not as ready to change your whole water system to go to a different water system. And so it was through that informing, educating, and communicating with all people from federal, state, NGOs, from universities that came together to create that project and to create those transitional watering points. But had it been a singular entity, I don't think it would have had the success that it had to reach the communities like it has thus far.
May I just add one thing to Nikki's comment, if I would, because Nikki knows that I've been watching this closely, and I've been talking about this and helping Nikki and her colleagues from the Navajo Nation help educate non-Indigenous people about these issues. The lack of access to water has been a chronic problem. It's not a sudden issue. It's not like a canal broke and suddenly there's no water, or a treatment plant stopped working and suddenly there's not clean water. This is a problem that has existed for some time. And there's all kinds of reasons one could give for why there's this lack of access to water. There are solutions to it. It took the pandemic to bring greater attention to it. And the good news is it's being addressed in ways it hasn't been in the Water Access Coordination Group and other efforts, which is great. But I mention this in part because will it take us getting beyond the point from which we can recover, from which we can bounce back, for action to occur? And I think that's an open question. You know, we see in the West often it takes some kind of crisis for some policies to change. And that's not the way you want to build your policies in these challenging times. But I think it's really an open question about what is it going to take to bring some of the significant changes that must occur, and will things get so bad that we can't get back to a point we want to be at?
Sharon, if I may, so do you think that the crisis that we are now experiencing in the American West and the Southwest in particular can really address that, what is kind of the elephant in the room here, like the overuse and misuse of water in the Southwest, environmental misuse of the water in the Southwest, like with 75% of water being used for agriculture, that's alfalfa and lettuce and these sort of things.
Honestly, I don't think we're there yet. I think there's more momentum and more understanding of the need to change, but I don't believe things have gotten that bad yet, that we're ready for, let's say, some of the significant shifts that some believe have to occur. That's just my personal view.
Yeah. Mm-hmm. And without looking into this extreme changes that might be desirable, just looking at the current assessment of things, like when we look at how water is used, how much water is actually being used by the ecosystem itself without humans in the picture, is not taken into account. So just factoring this in the equation would be a major change in how the situation is being assessed and how solutions or elements of solutions are being discussed and searched for. So do you think that this kind of change may happen in response to a crisis like the one that we're experiencing?
Well, hopefully, I mean, I think people are hoping that over the next few years, there'll be a serious look at some of the allocation and utilization issues, because there is a process that has to renegotiate the shortage sharing guidelines. But whether I did see there was a question about agriculture, and a lot of the agricultural use has to do with the laws and institutional structure. And so you may have the water owned by the government, but there are rights to use the water that are difficult to change. And I think there are going to have to be some very tough and serious discussions, and it will take some time. I think we'll see some change. The question is, what is it going to look like? And how will people mitigate some of the adverse impacts economically? I can't even speak environmentally at this moment, but even economic impacts, as some sectors may be more adversely affected than the others, to get a general enough buy-in to get the decision makers to implement some of the changes.
There are actually a couple of questions on agriculture, and basically the gist of these questions is, shouldn't we radically change, our conception? And I think that's what you were saying, Regis, of how we eat, how we produce, and very quickly. And here, that's when we have no idea, apart from the fact that the time scale is rapidly changing, as you both showed us. It's not a question of linear change, but we don't really know at what speed things should be done. So because of that staggering number. 75% of the water used is for agriculture, and I'd be interested to know within that 4-state area, how much does the Navajo Nation actually use in terms of water? But how, do you have any idea on how to address these rapid changes that we need in our lifestyles? And I think that will be the last question.
I'd like to hear from Nikki if she's willing to offer. German, I'd like to hear from them first, and then if there's time, say something.
German, Nikki?
As far as, so I guess just from a cultural context and how I was brought up, so we were not necessarily thought to make rapid changes as such, that there was this notion of respecting your previous generations that have come before you. And so it's just with the very different levels of knowledge that was gained at different times and your different human experience and the time periods you lived, I feel that that could apply to the situations that we're in now to try to see more the understanding of why things occurred the way they did in whatever topic we're discussing. For example, this agronomic production rates that were occurring in the past and occurring now, and how they will look into the future, and to really interlink those different time periods and perspectives that people had at that point for making those decisions. That I feel that when we look to the past with a more of an understanding, I think that we can start to create policies with a greater foundation of understanding for the future, to understand where people were coming from at that time. But now, with the knowledge we do have of a exponential change of human population increase, the impacts of climate changes, and how those adaptations are going to be made, I think can come all into play in that aspect. So it's not to necessarily throw out everything, but to use the basis that we do have and work from there.
I do totally agree with you, Nikki, and it's not always necessary to do big steps which are really longer to inputs. If we take the example of the formation, it begins with an awareness, and after a global formation, it's something which is we've got a continuum. So I totally agree.
You mean start with that first awareness and knowledge, and then move towards building sort of a global coalition of knowledge, which is what we're trying to do. I've got to say, Nikki, I really appreciated your insight in associating different systems of knowledge, and that's, I think, a big step that we all have to take in the global knowledge community. If there's a last sentence from all of you, I will take it now, and then we'll have to say goodbye to our audience. So maybe in the order of speech, we could start with Dr. Ferrier.
Yes, thank you, Emilia. Yeah, I just wanted to add that I really appreciated Nikki's emphasis on perception. And I think that tipping points, the concepts, the models, brush a dire picture of our environmental future, but there are also positive tipping points, and that's what we should be looking for. And current modeling efforts show that how perception plays out is really critical to reach, to define and reach positive tipping points towards better futures. So I think that that we are on the right track by approaching the problems the way that Nikki described today. Thank you.
Yeah, and I will just leave on an optimistic note of that glass half full and half empty. And I just, I pen a series of reflections essays, and tomorrow one will come out about the spring semester teaching my graduate course in water policy in Arizona and semi-arid areas. And I talk about the papers the students wrote. And I believe the students and the young professionals are eager to tackle these challenges. And it is going to take the collective village and wisdom and so forth. And so as much as I may talk about the wicked problems and the challenges, I'm optimistic that we will figure some things out by working together. So I'll leave it at that. Thank you.
Yeah, so thank you for the opportunity to present today. And I would just like to close with a phrase that we have in our tribe, and that's the Bila Ashkla'i. And so what Bila Ashkla'i means is that we're, is like basically the human race, the five-fingered people. And so if you look at your hand, you see these, you see your fingerprint, and at the bottom of your feet and under your toes, you see that kind of print as well. And how we're taught is that that's the whirlwind that connects you to the sun and to the sky. And so as we remember our place in the universe connecting to the environment, I think that we as human individuals living this human experience will be able to understand more of that inner relationship of how we are all connected living on this one planet and addressing these issues that we're talked about today in regards to desertification and drought and searching for solutions of our one home.
I just want to thank Nikki, Sharon, and Regis for the presentation. And last word will be in order to act on those global issues, we need to be formed.
Thank you very much, Germain. So once again, it was wonderful having you all enter this conversation. I have thoroughly enjoyed the discussion with you. I feel highly stressed now, of course, but I thank you for the positive note of your closing remarks, and I look forward to seeing you soon. Thank you to our audience, and this is the end of our second conversation on global challenges. Goodbye, Arizona. See you soon.
Hi, everyone. Thank you, PSL.